Aviation now accounts for 6.6% of greenhouse gas emissions. Modern planes run on kerosene, which emits harmful carbon dioxide into the atmosphere. But what if there was an alternative? One possible solution is to use a new type of fuel that does not emit harmful emissions in planes: hydrogen. In this video, we'll take a look at everything you need to know about airplanes on hydrogen. Long hyped as a sustainable fuel, hydrogen is now gaining traction as a viable option for aviation, with tests already underway to demonstrate its efficacy. Planes powered by hydrogen would emit only water, and preliminary tests show that they can travel at the same speeds as traditional planes, carrying more than 100 passengers per flight over thousands of kilometers. According to a recent report on the potential of hydrogen-powered aviation, such planes could hit the market as early as 2035. There are still significant obstacles to overcome. However, if they can be overcome, aviation's future could be much greener than it is today, and it could be a functioning component of a decarbonized world. Hydrogen planes would look similar to traditional planes, albeit with a slightly longer length required. Propellers would most likely be used in smaller planes, with hydrogen-powered fuel cells providing electric propulsion to turn the propellers. Larger aircraft could use hydrogen to power their jet engines. The Hydrogen-Powered Aviation Report, released on June 22nd, stated that hydrogen could be used to power a commercial passenger aircraft for up to 3,000 kilometers by 2035. A medium-range flight of up to 7,000 kilometers should be possible by 2040 or later, leaving only long-distance flights for traditional aviation. A variety of factors will be required to achieve these objectives. To begin with, hydrogen storage technologies must advance in order to carry enough liquid hydrogen in planes for these journeys. New methods of transporting hydrogen to airports will be required in order for planes to be refueled on runways. Interior redesigns will also be required to figure out how to integrate all of the necessary systems and tubing to run commercial planes on hydrogen. However, progress has been made in developing the underlying technology of hydrogen planes. Boeing flew the world's first hydrogen-powered plane from an airfield near Madrid, Spain, in 2008, proving the technology was feasible. In 2016, the first four-seater hydrogen plane lifted off from Stuttgart Airport, built in Germany by the German Aeronautical Research Agency, the University of Ulm, and a company called H2Fly. A storage system to safely store liquid hydrogen, fuel cells to convert hydrogen to electricity, a device to control the power of the cells, and a motor to turn the propeller are the four major components of a hydrogen plane. All four planes of these areas must be sufficiently developed in order to manufacture full-fledged commercial planes. The majority of the world's hydrogen is now produced by reforming methane from natural gas, a fossil fuel that emits carbon dioxide. In short, there is no single solution to aviation that does not involve the use of fossil fuels. To understand where hydrogen fuel cell technology fits in, a quick and broad overview of non-fossil fuel options is in order. Electric aircraft powered by batteries are already in use. Because of the energy density required to get an aircraft off the ground, these are only considered feasible for smaller, local aircraft. Sustainable aviation fuel will theoretically be able to power regional aircraft. But more development is required to have aircraft running on 100% SAF, while also removing the remaining CO2 and toxic emissions. Nonetheless, these fuel types are generally not regarded as feasible in the quantities required to meet current demand. Efforts are being made, however, to develop green hydrogen by converting water into oxygen and hydrogen using an electric current generated from a renewable source, thereby reducing emissions in its production. If this is possible, and there are no emissions from the planes themselves, aviation could become a truly green mode of transportation. Of course, not only aviation will need to adapt, we must all work together. However, we cannot combat climate change unless aviation is decarbonized, and it's possible that in the coming decades, your flight from Paris to Madrid or Munich to Rome will be on a green, clean flying machine that emits no emissions and has no impact on climate change, providing an exciting glimpse into our decarbonized future. And with that being said, it's time to end our video. Subscribe to the channel for more amazing videos like this, and we'll see you again with another interesting video.